Hello, everyone. Good afternoon. I was just thinking about good morning, but that's entirely wrong. I was in a session this morning, so I need to catch up. It's 4:45. Welcome to the session. Welcome to Amsterdam. Welcome to in-person Cisco Live Europe again. Quick comment for those of you who need assistance with listening. There are some headsets in the back, so if you want to grab one, you can do this anytime for sure. So welcome to the session about SD access and SD-WAN. On what is Wednesdays today, right? So I'm pretty excited to run this session. I did the same session or very similar session back in Melbourne. And we do live demos today. So I show you most of the stuff really under the covers with DNA Center we manage and on the boxes. We have some VPN issues here at Cisco Live we encouraged. So it may be that I switch to the recorded demo. So please forgive me. It's not my fault. It's all real. It's all up and running. But if the VPN goes down, I cannot access my lab anymore. So we look into the session. Oh, come on. Thank you. Yes, please. Into the multi-domain approach. I'm looking into multi-domain for multiple years now. And you see my dog. And I will talk a bit about my family and bring them in alignment with the session itself. Even my kids were able to draw pictures many years ago, which are still applicable. So we get a quick teaser into it, but I promise I don't bore you too much with my family. But even the dog, we need to satisfy everyone, right? We need to make sure that connectivity is kind of seamless for users to services. And it's really about building integrations fluently, making sure that we have proper services, but we can also enhance this, and that's where we spend a good amount of time with policy, group tags, micro-segmentation, and a certain amount of security. So, in the old days, there was a configuration of a router, right? I mean, it's just an extract. We have routers with, I don't know, 50, 60, 100 pages of code. Do you? Anybody still doing this all manual? All the engineers in the room, right? It's a lot of fun, makes a lot of fun developing this, understanding all the CLI. But if you need to repeat it over and over on many devices, it may get boring, right? But it needs to run. So we're not going to focus on the full automation of SD access. We're not going to focus on the full automation of SD-WAN, but I give you the insights to get everybody up to speed. But by the end of the day, we will see how we do the NNI between SD access and SD-WAN. Anybody still aware of NNI? It's a very old term, right? What is it? It's ATM, yeah. It was also an MPLS. It's network-to-network interface. It's pretty much routing. But nobody calls this anymore. Now we call it integration, pairwise, what have we, border node, fusion devices, confusion devices. Okay, you treat it as confusion device? Yeah, I will talk a little bit about confusion or fusion devices. They play a pretty important role, but we get into this one. We talk about the why, we talk about the baselines, we talk about what we do, we dig deeper into it, we do some policy. You can ask any question. I have a WebEx Teams room open. If you have questions, you can post them in. If you want to ask questions during the session, I will take a few. Depending on time, I will ask you to come back after the session, because we have just an hour. The topic may cover easily more than an hour. I'm German. You may hear it. My accent may be bothersome to some of you. If something goes wrong, you don't understand me, ask me. I try to best to be as crisp as possible and, I mean, understandable by the end of the day. Who has the following challenges? End-to-end policy. Take the cool one. Policy end-to-end. Micro-segmentation from the branch all the way to the data center. Anyone? A few? Not yet. Planning for this? Looking into this? Yes, you're here, right? That makes a lot of sense. About automation across the domains? I assume for sure, right? How many of you do automation? Okay, still not a lot, right? It's interesting. Why don't you do automation? It's too heavy. It's too much work. Automation costs more resources than no automation. Yeah, true. I mean, it happens, right? Because if you want to go into the automation world, you need to spend some resources to develop a proper automation. I mean, even DNA Center and SD-WAN we manage does something, but you need to understand it. You need to train the people. You need to bring it to operations. So in the beginning, it takes more, but over time, it should give you a return of invest. So that's all what we are looking into. Back to me, short introduction. I have two kids. They were presenting with me. I mean, not the kids, but they were doing the drawing when they were 4 and 6. Today, they are 12 and 14. And the fun piece, they have had a glass ball these days because they were able to predict that I do APKM, do you know, recognize your network, then do SDXs, can I automate this network, then do multi-domain integrations, and today it's about the campus, which is the drawing on the top all the way to data center and cloud connectivity. It's awesome what they did. I didn't make a single dollar out of it, that's the problem. So this is actually a journey I'm coming from. I'm Markus Habeck. I'm a principal architect in CX product management. I was working in sales as a lead sales engineer for DNA Center and APKM the last 10 years, and now I'm on we call it the dark side of the house in Cisco. So we're building services with a lot of automation and integration, and we want to ensure that we can assist you, your partners, or if you're the partners, to bring up this environment and to understand it deeply, because all my colleagues within the customer experience organization are the forefront. They are really the ones who are guilty, who needs to be at the terminal and bring all this stuff up. I have 2 kids, as I mentioned. I have a dog. I'm 12 years in Cisco. And my focus I already mentioned to you. I love to do whiteboarding, which is a bit challenging during a breakout. So what I do, instead of whiteboarding, we do a couple of demos throughout it. The session focuses today around DNA Center and vManage, means SDXs and non-SDXs, because whatever I talk about is applicable even if you don't run the fabric, it works. And SD-WAN vManage. I'm not talking about ACI too much. If you have questions how to integrate with the data center, we can take it offline. It was a separate session. We postponed the session a little bit because of roadmap changes in this integration. But you can transport your microsegment also in the data center. It works. It has a couple of caveats which we're going to close. Good. Some basics to start with. How many of you are aware of Campus Fabric? Oh, you know the story on Campus Fabric. How many of you on SDXs? Where's the difference? Sorry? DNA Center, correct. Campus Fabric, you can configure everything on your own. You can use DNA Center to do all the work for you. It's not easy. It's about, 2,000 CLI commands, something like this, but it works. You can do this. So the major thing is it's based on DNA Center and Identity Services Engine if you want to do TrustSec. You can run SDXs no eyes, but then you don't get group text, you don't get identity 802.1x, but you can run it with a radio server if you want. So that's going to work. But in general, you need DNA Center. If you go under the covers, it's a fabric. It's based on VXLAN. We have so-called edge nodes, because access switches is too boring and not heavy enough for CCIEs, so we need to change the name. Right? It's like border leaves and spines, and everybody has its own terminology, but by the end of the day, they all do the same thing. So edge nodes are access switches. Intermediate nodes are the ones you don't see because they are kind of distribution and just IP forwarder. And then you have the border nodes. The border nodes are connecting to this confusion device, to the fusion device, of course. So that's the external connectivity. We have the control plane, and the control plane is based on Lisp, Locator ID Separation Protocol. How many of you know this? Awesome. I like Lisp. I like that you all know of this. I did a lot of sessions on Lisp. It's like DNS if you don't know it. It's giving you the idea where an endpoint is connected. It pretty much works like name resolution, and that's how we build up the routing table. It's super scalable, and it's built for mobility. These are the major differentiators to BGP. We could have done it with BGP. Nevertheless, we will get EVPN BGP support into DNA Center as we speak. I'm not sure if it's in the current release, but it will be in the upcoming releases. We get this app as well. So you have the choice to run SDXs versus EVPN. The major difference is microsegmentation. That might be an issue on EVPN because there is maybe some limitations on that one. So that's what we bring together. You can add your wireless controller as well. If you add the wireless controller to Fabric, your access point will speak VXLAN from this given moment on, if it's connected to an edge node. So it's being integrated into the SDXs fabric. And this gives you then identity plus microsegmentation and all this stuff. The power with it is really the automation on top, the single IP pool, the automated handoff to the fusion device. All this is being configured under the covers. I'm not going to scale deployments to multiple fabric sites. It's more about the generic approach, what we do in SDXs, because it's just to make sure everybody is on the same page. So how many of you are running SD-WAN? From Cisco, by the way. SD-WAN is a very generic term, while SDXs is a very Cisco term, if you want. So SD-WAN, very similar concept. We don't really treat it as a fabric. It acts like a fabric. There's no spanning tree in the wide area network, so the fabric approach on campus is a little bit different. It solves a couple of problems. Broadcast domains are smaller, etc. In SD-WAN, it's very similar. You have the edge nodes, and we call them C-edges. Funny enough, another name. But it's the access router, it's the CE router if you want, it's the terminating router, which gives you the handover interface into the branch, into your headquarter, so where you connect your campus network. It's being managed through a couple of components. We have vSmart, taking care about all the control plane approaches, and the control plane in SD-WAN is OMP. It's not Lisp, it's not BGP, it's OMP. They have all something in common, they do routing. As simple as that. It's being built for a purpose, it is being optimized for SD-WAN, that's why we have it. We have vManage as the orchestrator if you want the user interface, the dashboard you're going to use to bring up the templates, to onboard the devices, to manage the devices, to get some analytics data, to give you API access. And then finally you have vBond, which is taking care about the configuration distribution across the entire infrastructure. The only thing you normally worry in SD-Access is DNA Center, and the only thing you normally worry in SD-WAN is vManage for all the configuration purposes. Of course, if it comes to troubleshooting, it's a bit more complex from the system perspective. One important thing to know in SD-WAN is there are two reserved VPNs. VPN 0 for the transport, and VPN 512 for the out-of-band or management inside the network. All others can be used. Just for your reference, I'm not digging too deep into this. I'm more focusing on the two, how they come together. So I built a table just for you to ensure, okay, where are the different functions in the architectures? So we do have DNA Center and vManage as the user interface, as the management piece if you want. We do have a control plane on each. Of course, they have underlay control planes. In SD-Access, if you automate it, you're forced to ISIS. If you do it yourself, you can run any routing protocol in the underlay. In the internet for SD-WAN, you may have, I don't know, a default route. You may have just DHCP, you may have BGP, you may have, I don't know, how you connect to your provider. It can be anything. But the overlay routing protocol, this is where the power sits, is actually Lisp in SD-Access and OMP in SD-WAN. And I will show you how they interconnect in the control plane. If you come to the end of the session, we do a bit deep dive into what's happening in the boxes. DNA Center wants, and there's no workaround for this, to communicate with the SD-Access switches in the global routing table. Not in the WRF, not in out-of-band management. That is something you please keep in mind. If you design your SD-WAN, I need to connect DNA Center wherever it sits, data center, doesn't matter. I need underlay reachability in my SD-Access. Same for ICE, right? So that's something we need to keep in mind. We call them routing locator. These are the identifiers of the edge nodes and the border nodes in the control plane. And we call them T-lock, transport locator in SD-WAN. So even the same idea, the same concept behind it, it's about the tunnel sources. And the tunnel in SD-Access is VXLAN. And the tunnel in SD-WAN is IPsec. Right? So we built an any-to-any fabric in these cases. We talk about virtual networks and VPNs. It's always the same thing. We just switch acronyms as we like, but that's how it is. And we have SGTs, and SGTs are being added or bind to a source IP address in SD-Access, and they are enforced on the switches. And SD-WAN just takes care about transporting or forwarding SGTs. It doesn't do anything for now. Good. Some latency considerations for you important, because I said DNA Center needs to talk inside the underlay. That also means that we have some latency restrictions. I did the same demos as I do here in Melbourne. I did a recording because it's 350 milliseconds away, and DNA Center doesn't really like this. So the demos were very slow. That's why I recorded. In here, it will work. I have like 80 milliseconds or something to Frankfurt. Good. OK, let's dig a little bit deeper into it. What did we do traditionally? NNI. Network-to-network interfaces, a router to a switch. Sometimes it's just a VLAN, as simple as it is, and the router is the default gateway. Nowadays, locations are getting bigger and bigger, so you most likely have local routing, so you need to do routing between the two. And this is still an important piece, because now what's happening is route redistribution. And that is a very critical piece in an infrastructure. Because if you just do OSPF to BGP, and then on the other router BGP to OSPF, and maybe you have EIGRP, that's a lot of fun, because it's not only about spanning tree loops, it's also about routing loops. So it needs to be covered, it needs to be filtered, that you can ensure that your network-to-network interface is not causing any routing loops. How do you detect a routing loop? How do you see this as an administrator? TTL is expiring, right? So you send the packet back and forth until we have 255 hops by default and drop the packet. That's as simple as it is. So we take care about this one. We transport the VPN, but we do not transport the SGT if we don't enable it. If we don't have SD-WAN, it's even been dropped because a traditional router doesn't understand this in SD-WAN. And that's what we have changed in SD-WAN in 17.3, I think. That was the first release. And the first really to-go release was 17.6. And that's where we started to transporting SGTs. And I'll show you where the SGT sits in this case. Good. DNS Center takes care about the campus on all ends. vManage takes care about the SD-WAN everywhere. And that's it. It's not integrated, so they don't talk to each other for now. And we call this then the two-box solution. I come back to this. What we need to do the integration is to build a network connection between the SD access border and the C edge, which in this case is not the Fusion device or the Confusion device, it's just the forwarder. The Fusion device is the guy who connects the new world to the old world, if you want, or to something external. So that is being done by Verve Lite. We call this IP transit in SD access. It builds you an underlay connectivity. It builds a VLAN per Verve, and it gives you the BGP connectivity to the external device. And you need to do the same reverse on the C edge, and I'll give you the details in a minute. And then you need to enable TrustSec STT transport. And here you can see in the middle that we now have added the STT layer in, and I'll come in a second to this, where we add this into the header. We call this independent domains. So campus and SD-WAN is still independent. They run on their own. They can be treated completely independent except this little link between the two. We call it two-box solutions. The major reason was we had integration between DNAC and vManage, and we are working on improving it, but we had a very strict version dependency between the two controllers. And we want to avoid this. We don't want you to make SD-WAN upgrades when you do DNA center upgrades. So that's why it's called independent. The end view is very simple. The control plane and border sits in SD access. The C edge is a C edge, as simple as it is. So that's what we look into in a second. Let's have a look at the headers. How many of you saw the VXLAN headers on SD access? I assume in one of the SD access sessions we did. So how many of you know why we have an UDP header in between? Perfect. Load balancing, thank you. Because if you just have VXLAN, you have no identifier for the flow, nothing, so you cannot do load balancing, and the source and destination is a loopback address. It's not like I have 10 links and I have 10 source addresses. I just have a loopback address. It's load balancing. That's why we have UDP. That's the main reason to have UDP in between. We have the VXLAN header. Within the VXLAN header, of course, we bring in the inner packet, and we do the VN mapping. So we bring in the virtual network identifier in. It's a Lisp identifier. Normally, if you see the configuration, it starts on 4099 and counts up, right? So that's how we bring this into the packet. So we have both in. The VXLAN header also gives us the possibility to transport an SGT by default, and it only adds an SGT if you enable TrustSec in the infrastructure. And I'll go and show you this during the demo. In SD-WAN, it's a bit different. SD-WAN needs encryption by default, right? It's super important. You cross internet, public transport, etc. So that means you need an IPsec header to encrypt the traffic. The UDP header is more or less for the same reason. You bring this together, and you have the MPLS header for VPN labels added to it to have VPN support in SD-WAN. In MPLS, we have 3 bits available to do something crazy which is not defined by the standard, right? They're experimental bits, and they are normally used for quality of service, right? So there's no space for 16 bits of security group text or scalable group text. Nowadays, it's called security group text again. Forgive me if I fall back to scalable. I was bumping my head, scalable, scalable, scalable. Last year they came. Now it's security again. Okay, it's good for speakers. So you keep trained your brain. So what we did is we set the next header in the frame to metadata, gives us a CMD header, gives us additional options to transport information, and we add the SGT, the 16-bit, into this one. It's not important to know in the regular operations, but it's important to understand that this has been enhanced. Means we eat up a little bit more of the MTU, but you need to deal with MTU anyway in SD-WAN. Good. Configurations. And I showed this to you live. We have DNA Center. DNA Center takes care about the SD access, of course. Edge nodes, intermediate nodes, wireless, border nodes, control plane, not about the fusion device, but we do IP transit and we do SD access transit. SD access transit in 2 flavors, Lisp BGP or Lisp PubSub. The PubSub is fairly new. That's internal communication. As soon as we go external, you can override BGP and do it statically if you want to run it through templates or manually. But if you automate it on IP transit, we do BGP. We take care of all the VRF configurations, about all the routing updates. If you get a new IP pool in a year from now, it's completely auto-distributed to BGP. The only thing, of course, the route map on the Fusion device needs to understand the new route and it needs to accept it. In vManage, we configure the C edge. In my demo, I do it via templates. I'm in vManage mode, not in CLI mode. That doesn't allow me to push any configurations through SSH or something, but it can be do either way. It doesn't really matter. And we, of course, need to adapt on the DNS center settings. So we need to agree, okay, what is my IP pool? What is my VLAN ID? And the beauty is that in DNS center nowadays, you can configure VLANs and you can configure the IP addresses. Like 2 years back, that was impossible, which was kind of tricky if you test around a lot. Because if you delete it and you redo it, you get new IP addresses and you always need to reconfigure the C edge. We solved this. This is now fairly flexible. My demo topology, pretty interesting to talk through. We have a client on the bottom left. It's Lubuntu 2. I don't have better names, forgive me. But on the right-hand side, I have Lubuntu 28. I'm not sure why I choose this complicated thing. So 172.20, 195.13, and 205.9 on the right-hand side. We have a fabric in a box in Munich. We have the SD-WAN, CH4, and CH2 connecting to a headquarter ASR 1000 all the way to a 9300 in the headquarter. That is the demo topology we will spend most of the time today on. So let me do, I know the slide will come in a second, but let me do those kind of things on the controller itself. Looks like I'm still connected to VPN. That's great. So if we go into DNS Center, you have a couple of settings to do, right, to bring it up. And I'll show you, we have created a couple of fabric sites. And first of all, you need to create a transit, an IP transit, if you start from the beginning. So we have, let me do this. I think that's easier to read. We have IPTMUC, and the only thing you give it is the remote and the local AS number for BGP. And you define, this is an IP transit. You can select it later in the border configuration. If I go back to my fabric site, in this case, you see I do have Munich, I do have the headquarter. These are the ones I'm looking for. Cisco Frankfurt is not part of the demo today. If I go into Munich, and we can even do this a little bit easier to read for you, then you see it's just a fabric in a box switch, right? Not layer 2 floating applied, but it's in here. So it's border control plane and edge node. This is a fabric in an edge. It's a 9300 standalone switch. It's SD access, but actually no VXLAN, because we don't send any packets out of the box. The only thing we send out is IP transit. You can have multiple fabrics in the box. Daisy chain, that'll work too, I think to a maximum of 5 or something. In my case, it's a single switch. So it's configured border, control plane and edge node. And if I look into the border configuration, because this is the tricky part for the integration finally, I have my IP transit from MOOC, and I have my Gigi 101, which is my uplink into the topology. And what I've done is as simple as I have a demo VN, this is my virtual network. I have assigned the VLAN 301, and these are my IP pools, my local address, my remote address, and this is where I do the static configuration. So now it's predictable. Nothing is going to change if you change anything in DNS Center. So that's what we have here. The other thing important to mention, let me quickly get in here, is the virtual network itself. You saw it already. It's demo 1. And I come back, we can actually go into this one and I'll show you the IP assignment on the one end side. And I've done exactly the same thing in the headquarter on the ASR 1K, just with other IP addresses. It's a different location, etc. That means you also need to have an IP pool pre-configured in DNS Center for this, right? It asks for an IP pool. So if I go here in host onboarding, I have my virtual network, I have my demo environment, and as you can see here, this is my IP range on the switch. So that is the DNS Center view of it, right? SDX is up in a fabric in the box. It's just adding control plane, border, and stuff, and edge node in one device, and that's it. If I go to, just to show you the headquarter, sorry for here, then you see that we have 2 ASRs, and we have 2 edge nodes. So this normally looks a little bit more like a fabric than the fabric in a box. But both options are valid, so I wanted to make sure that we can see this one. On vManage, it's exactly the opposite. So we need to reverse the configuration. We go into templates. I can have a look. This is my device template. So we go into my feature template. Sorry for that. We have a BGP configuration here, right? A BGP template. If I look into this one, you see it's my CH4 on the left-hand side in Munich as an example. So I'm not going through all the routers. I hope you believe me. And if I go into the template itself, you will recognize I've set up BGP, same AS number, and I have my neighbor configuration in here so that I can talk to 193, you may remember, the configuration of DNS Center. And that forms the BGP session between the two, as simple as that. So what it gives you, if I look into my FIAP device, my fabric in a box device, I have my various interfaces. So we have the VLAN 301, which is my handoff. I have the 121, which is the VN pool where my Lubuntu 2 client is connected to, right? And if I look into my BGP configuration, then you see that I'm learning already 68 routes from my neighbor. And if I go deeper, then of course you can see the full BGP table, and this is coming from the CH4 device, the CH device, which gives me the routing table. So what we do is we redistribute OMP into BGP, send it out to the fabric in a box device, and you learn the routing table. Best case, this is just the default route. It's my full lab environment. I was kind of not really following my own rules and filter everything out. It depends what you do. This FIAP can act as a transit in this case. That is the trouble on this NNI. If you forward all the routings, then it can be a BGP transit, and sometimes you want to avoid this. Good. So we have done this. Let me go back to the slides for the reference for you. I listed this in the slides. I think the demo videos, I can upload them if you're interested in the WebEx Teams room. There's a full demo video so that you can recall what I'm talking about. But I gave you also the configurations in here. So we have the BGP address family. We have the neighborship built up. All the configuration on the SDA side is coming out of DNA Center. And if I go to SD-WAN, I have then, of course, the reverse configuration coming out of the automated template of SD-WAN. And that is BGP to BGP. CH to SD-Access fabric in a box, can also be to a Fusion device. If you don't want to run SD-Access in the branch as a fabric in a box, because it's a single switch, and no, it needs to be a 9300 with a DNA Advantage license, etc., etc. If the switch is capable of doing SGTs like a 3850 or a 9200, you can run it traditionally, right? Then you configure SGTs on the switch, and you can still send the group tag to the CH, and it will grab the group tag and transport it. So it's not depending on SD-Access anymore. Good, that was my demo. So automation and all these things let you focus on what really matters. And that's what, I mean, focusing on this link, right? It should be proven that it is working in your environment, no doubt. But routing is a very critical piece. But even routing table and routing loops are critical. Is there a question? Was there a question? No. You have a question? How do you get a group tag from the FIAP to the CH? Okay. The question is, how do you get a group tag from the fabric in a box to the CH? Can I get 5, 6 more slides? I have the answer in the deck. We talk in detail about this. But thank you for the question, because this is what it is about. So, a brief moment about the design. So what we need to do in terms of design, and then I come to the group tag and the policy enforcement, what we do. And I show you exactly what needs to be configured. So the design in this case, it's all independent. Means we do have, let me do this. It's a little bit easier. BN, border node, 2 edge nodes. It doesn't matter where the control plane sits. The border node talks to the control plane. The DNS Center configures it that way. If the control plane is on an edge node, it doesn't matter, right? They find each other automatically. But the border node talks to the CH. They can be directly connected. They can be multi-hop BGP, but it's not recommended. Yeah, we can enforce this. I think the default eBGP multi-hop is set at 1. So we need to be careful on this one. DNS Center and ICE are required if you want to go SGTs. Right? DNS Center needs to have Identity Services Engine. It doesn't work the other way. If you don't go SGTs, just 82.1x, a radio server is enough. If you want to go full policy, you need Identity Services Engine to be integrated. You can start with just macro segmentation and routing, and add ICE later in a year from now and enable SGTs and TrustTech. That's not a problem. It works very smoothly. Nevertheless, bring it in the lab, test it out, figure out what's going on. You see on the left, we have my VXLAN header, SGT's VXLAN in this one. We have WRF-Lite between the campus and the wide area network. We have the transport on MPLS, IPsec, VPN through the wide area network, and on the other end to the other branch, we have this connectivity. For ACI, it's a different game, as I mentioned in the beginning. We do have an ACI integration. I'm not going to talk about this during the session in terms of time. One design thing is, if you look into it, that you use your Fusion device connecting to ACI. That will work too. What does WRF-Lite? WRF-Lite brings you an 802.1q trunk. As simple as that, nothing else. Old technology, well-known, hardened, and it supports SGT since, I think, 2004 or something. It's already in. So we just copy it over. The challenge is DNA Center doesn't provision this configuration to the border node. And I show you what you need to do. So it's not enabled by DNA Center. But we need an 802.1q trunk. That's what we do with IP Transit. We map the virtual network into the VLAN, into the address family of BGP. That's pretty much it. And that's where your SGT value is. Where's the VN ID, the VPN ID? It's a VLAN, as simple as that. Right? There's no virtual network in a trunk environment. I think we had this on the design phase, but where I want to go is, okay, what if I have multiple branches? So you can have branches, of course, with a single C edge, with single borders and single control planes. You can build full redundancy. You can mix all of them. All of them are actually going in an IP transit between the campus and the wide area network. And in my example, you see that I connect my data center to the border node of the headquarter SD access, which is also the case in my lab. You can do the integration. There's a phase 1 integration where you can really bring border leaf and border node together. Again, if you're interested, I'm happy to talk about this after. It has some caveats and some limitations today, so we're going to solve this in the future. So that is a way where you can communicate into the data center or to the external world, right? If you have more than one DNA center, you can do the same. It's all independent. So if you need to scale, you have thousands of branches, you need to run more than one DNA center cluster, or they are spread around the world. So one is in APJC, the other one in EMEA, etc. And the latency considerations comes in. So you can run multiple DNA centers, multiple ICE, bring this together. The SD-WAN will be your connector. And the beauty is routing like it was the last 20 years. So we'll spread the routes all over. And the group tags are simply transported in SD-WAN. There are no actions, no dependencies on DNA center to have this. OK, now I come back to your question. So what we have, first of all, virtual networks. Important to understand. I think everybody knows about virtual networks. It's kind of a virtual router in a router. It gives you a routing table separation. Virtual networks between each other cannot work unless you have an external connection or a route leaking within the box. As simple as that. Pretty old technology from the old MPLS days, whatever you want. It's rocket science. But you have all the segmentation. Within a WRF, within a virtual routed and forwarded network, within this routing table, it's an any-to-any non-protected environment. So all the devices can talk to all the devices. It's just routed. And that is the challenge where we're coming in. This is where customers came back and say, OK, can we limit this? As simple as my user sits in the demo VN, and the printer is in the same virtual network, and I don't want the user to connect to my printer through HTTPS or through SSH. They should print, nothing else. And this can be just because the user is not allowed to. This can also be to protect the printer for any attacks. Right? We expect UDP, whatever, 1900 to print or whatever the protocol is. And that needs to be achieved. It's pretty complicated in one routing table, but you can also bring firewalls in front of the printer. It's not a lot of fun. So what we have created was TrustTech many years ago, 2004 or 5 or something, maybe earlier, which gave me security group tags. And the security group tag is something I can bind to an identity. And in this case, the identity is an IP address. Right? So I tie it to the IP address, and I can do this on multiple ways. First is, as simple as it is, a static binding for the port. I connect to the port, I get the group tag. The second thing is I do a static binding, for instance, in ICE, and say 1, 2, 3, 4 always gets SGT 113. And the next one is, of course, 802.1x. I do this dynamically. It doesn't matter if you do MAC authentication bypass or full 802.1x. It's about pushing a policy back and saying, okay, this guy connected, it's identified as SGT113, so I touch it. And even if this endpoint roams through the infrastructure, the SGT will kind of be sticky to the device. So that's why we bring this together. Attached to an SGT, you are able to attach an SDACL, a security group tag ACL, access list, which means you can now filter and say SGT113 to SGT120 is allowed for SSH or printing, but not for ICMP or something. You can also do the same SGT113 to SGT113. It doesn't matter, it can be the same number scheme. So you can build an ACL to do this. I treat this as a first demarcation or first line of defense, if you want. It's not a stateful access list. It's not a firewall replacement. It's not an application firewall. It's just a pure layer 3, layer 4 access list, as simple as it is. But it solves a lot of problems, and it normally mitigates any attacks into the infrastructure. The next important thing, by default, and we're going to change this, I'm not sure how far the roadmap is, to be honest, but at the moment, the SGT ACL enforcement is done egress, when you exit the infrastructure. So it means I can send the packet in, it will go through SD-WAN, it will arrive at the end of the topology, and it will be dropped by the destination switch. That is important to know. And there's a reason for this. The reason is TCAM scaling. Because if I do egress, I know where the packet is going, I can program the destination exit. If it's source-based ingress, I need to program all the ASICs worldwide for every SDACL, because I don't know which traffic is arriving where. Right? This is one of the reasons, and there are many more, just to give you one note on this one. So for the configurations, again, vManage needs to be enabled to transport SGTs. And the important thing here is that I need to enable, and you see the CTS manual command. I go back to the console in a second and show you the details. You need to get this into the configuration, and vManage gives you a template to do this. It's just a check mark in it. And you need to enable the tunnel interface for this, and this is new. There's a slide, and I show you the slide, but just to keep in mind, before 17.6 and 26 SD-WAN, SGTs in 17.3, 4, 5, and 6 were transported by default. And they changed it from the product. In 17.6 and ongoing, it's disabled by default. If you want to transport an SGT, you enable it again. And the simple reason is, if you don't use SGTs, why should I give you an MPLS CMD header? Right? I remove MTU from the frame. If I don't need it, then I have more capabilities in terms of transport. That's what we do. And that's what's in here. And I show you how to come to this point. It's really important state to understand. If you migrate from 17.3 to 17.6, the behavior is different because your SGTs will be dropped. Right? If anybody running this already, SGT transport? Yeah, 2, okay, 3, yeah, perfect. So keep this in mind. If you're not on 17.6 or 9 already, then it will most likely fail. And this is how it looks like on the vManage end. So let me go into vManage and show you the template for this one. Again, we can filter in my template table. It's very straightforward configuration. So I do have my gig 002 interface, which is pointing to my fabric in a box switch. And what we do here, if I scroll down to TrustSec, I'm actually configuring, and let me do something to make it easier to read. We have enough space on the screen. So we need to enable SGT propagation on this interface. And this will push CTS manual to the interface. Right? So the upper one. The second one is actually then propagate this out. So I accept the SGT and I propagate the SGT within my box. And that's important because with 17.6 you need to enable SGT transport. That means you need to go to the tunnel configuration and allow SGTs. Otherwise it will just be dropped. And then you can say I trust SGTs. In my case, I'm going to trust a single SGT 113, right? So I can have kind of a pre-filter what's going on the CH box. And I need to allow this. So it's kind of a permit list model to get the group text transported. Okay? Good. If I go back to my templates, and if I go to my gig 001, which is the interface, the TLOG interface, forwarding it, we We have the same thing, and it's actually a tunnel configuration. So if I go into my tunnel and scroll down to the very bottom, the good thing is that you have the CTS propagation flag, and this needs to be switched on if you go 17.6 or later. So that gives you the configuration on the C edge. Let's have a look. We have all of this here. Right, so we have the gig interface pointing to my fabric in a box. This gives me my CTS manual with my trusted SGT. It's a static SGT in this case. Can be multiple SGTs, of course. Right, so I trust the interface. And the second command is, I think it's tunnel 0 in my case. No. Oh, yeah, of course. And then you have the tunnel 0, which then enables the general SD-WAN to transport group tags. This is happening on the SD-WAN side. Sounds more complex as it is, because you just need to configure tunnel 0 once. And then, of course, you need to understand which interfaces are expecting SGTs on the trunk. Okay? Important to know, if you enable TrustSec, CTS, on routers, and you run sub-interfaces, in my headquarter, I have a trunk between, even in the branch, I have the trunk between the border node and the C edge. And if you enable CTS, it will bounce the interface. It will go up and down, it will flap. You need to reconfigure the interface, so it goes down and up, means it reconverges. Important to know if you need to have a maintenance window for this, right? Because it will disrupt. It's only a few seconds, but you know, if it's down, BGP needs to come up, all the routing needs to be in place, etc. Question?
Once back to the SGT trust.
Yes.
Does it mean you have to put there all the SGT I will transport?
So the question is, if I go back to the SGT trust, we have it here, right?
Do I have to mention all?
So you can make a permit list and you don't have to mention all. In my case, I filtered down to 113, so you can have like accepting everything if you want. So you don't have to add, like if you have 50 SGTs, you don't have to do this.
Okay, so I just
yes.
all the SGTs will be transported.
Correct.
Okay.
Good. So that's on the one end. That's the C edge. This is automated. Cool. I love it. Now we come to my fabric in a box. So we have another interface. I should have automated it, right? Here we go. Same thing, same configuration. So I have this nice configuration, CTS manual policy SGT 113 trust. But manual, thank you. You're right, it's manual. Manual, what does manual mean? Oh, I can write a template and push a template to the device. So write a template, attach a template to a network profile, go to provisioning, provision the device, it will work. Or just go SSH into the device, copy and paste it in, it will work too. It's not being overwritten. Both steps are allowed, supported, and possible. But it's manual. We are still asking for getting this automated in DNA Center. It's still not in. It's on the roadmap, not sure when it comes in. So that is a big thing, because if you have configured everything right, the border node doesn't send any SGTs. It's just dropping them as the CH does when it doesn't know about it. Sorry for saying this, don't shoot the messenger, but it's how it is. Okay, that was actually what we configure in the infrastructure. So that was the trusted configuration. Good, now we have everything in place. But we didn't attach any group tags to the endpoints, right? So I just showed you connectivity. It's all about measuring connectivity. Please keep in mind, if you configure TrustSec, so I had it in my lab too. I do out of band, so I'm lucky, but if you don't have out of band and you misconfigure it, you may drop your connectivity, because if the SGTs are somehow not allowed by the C edge or by the fabric in a box or by the border node, it's gonna do a deny by default. It's like an access list, right? If I don't know about it, I just drop it. And that includes routing protocols. So be careful when you configure it. There's a way, there's an order, which doesn't impact the infrastructure, but if you just play around and like me, copy and paste without out-of-band management, for me it's then 45 minutes, right, to fix the problem. Or I have a good friend now in the CBC who's taking care about this. Good. Demo topology, you're aware. What I do is as simple as SSH and ICMP. So I have a rule here on the bottom. I permit, in my case, for ICMP and ID and permit for SSH between the two endpoints to make the demo simple. Of course, these SDACLs may be way more complex, right? Printing, RDP, whatever you have in this case. And we're gonna go into a deny modus on the slides. In my case, I show you a monitor mode. You can also test it out within the demo so that you get this information in the demo. Again, DNS Center manages this SDACL. If you enable access contracts in DNS Center, it's gonna give you or throw you a warning and says, if you take over SDACLs by DNS Center, it will be read-only in Identity Services Engine. So the very first time you do this, and you accept it, DNS Center will configure ICE and say, I'm the master of SDACLs, and when you go back to ICE, it will be read-only. You will see all of them, but you cannot modify them anymore. It's all DNS Center. That's the idea behind it, which is fair, but if you don't want this, then you need to run all the SDACL configurations within ICE. Good. Let's go to my endpoints. We talked a lot about the endpoints. So we have this, I made it big, I hope you can read it. It's, you can also do this way. We have my .13 address. We have my out of band, which is surviving me, hopefully, during the day. No, nothing will happen. And I can go and ping to the other hand, right? The Ubuntu 28 has the IP address 205.9. So I have reachability. I can do the same thing, reverse, so everything connectivity is granted. If I do a trace route, if you want, as an example. No, yes. 13, it's gonna do nothing. On the other end, it works. Whatever it does here, too many fabrics. It's live demo, is it? Let me do this from here. I think it was a IPv6 trace route, or am I mistaking? No, sorry. This is better, much better. So you see, I have a couple of hops in my lab. I go through my border node, I go through my CH, my SD-WAN to my headquarter device. That's pretty much it. So I have connectivity here. I can also do SSH into my, here we go. My remote Ubuntu, which is now Ubuntu 28 in this case, as you can see here on the bottom, right? So all this connectivity is working. Why is it working? CTS is enabled, as you saw. Let's have a look. What happened? We go into DNS Center. We go into the policy configuration. We go into group assignments. First of all, what I've created is a group tag CL demo 113. Why did I choose 113? I don't know. I like 13. So that's how it is. They can come from ICE, but it's a predefinition what you want to do in this case. Okay, that's the first thing. The next thing what I've done is, actually, I went to provision to my fabric sites. And then you go to, in this case, Munich, or we can also go to headquarters, it doesn't matter. And you have this host onboarding tab. I showed you in the host onboarding, we have a virtual network. Within the virtual network, we have the IP address and pool assigned. That's all good. So what next is, since I don't run, to remove complexity a little bit, 802.1x for this demo, I go to the port assignment here, right? And if you look into the switch, I can sort it by link status. 1/013 is my device, where I have my device connected. And actually, I did a static mapping here, security group tag CL demo 113. You can use the number or you can use words, it doesn't really matter. So in this case, every device connecting to this port will get an IP to SGT binding of SGT 113. It doesn't matter which device it is, which is not really protection, but it simplifies the demo a lot. If you want to go 802.1x or any kind of authentication mechanism, then the SGT is being assigned by Identity Services Engine, because you create a policy and say, oh, Markus logs in, he gets 113. I don't know. Josh logs in, he gets 120. A phone connects, it gets 200. The printer comes in, it gets 300. It's the policy within Identity Services Engine. It's very powerful. You can use all the features of Identity Services Engine. The result in this case will add the SGT. Okay? Good. That's where we have this. So we go back to my access contracts. sorry, not to the fabric. We have been to the fabric. We go here. So we have the group tags. I've created the contract, and let me quickly pull the contract. And what it does is exactly what I've showed you. Let's do this way. We have deny. We have a deny for ICMP and a permit for TCP. Why is it working? I already mentioned it, or did I? It's in monitor mode. Thank you. Right. So I put it in monitor mode. But where? I'll show you in a second. Here is the way where you create your SDACLs and you can reuse it for any communication. Right now, the next step is attaching the SDACL to the group tag relation. That's what I'm going to show you in a minute. But you can reuse these ACLs. You don't have to rewrite it for multiple communication ways. And that's actually where it is. You can just edit. It knows a couple of protocols. You can do custom protocols in here. You can lifecycle it. It even raises a change request if you are ServiceNow integrated. So that's something new we brought into the system. And finally, if we go to policies, and don't ask me why we have ordered it this way, but you go from the middle to the right to the left, but that's how it is. If you go into policy, you figure out that we have CL demo 113 over here. And if I mouse over, then I have my communication. In my case, it's the same group tag talking to each other, but it can be different group tags. And that's how I built in the policy. And even if I click into this one, that's where I really go into adding the contract. So by default, if I take a new one, just to show you, we click somewhere, the contract is enabled, we can do change contract, I will get my contract list. I connect CL, the contract CL demo 113, I can edit it from here, I can just add it to the system, change it, and it will be in the system. So in my case, the contract is already attached and it is in monitor mode. Even if you change monitor, enable, or disable, or create a new contract, you can do it. Nothing is gonna push to the infrastructure. Nothing is changing. So I'm actually in monitor mode. Let me check if we are really in monitor mode. So let's go to the fabric in a box. Let's take the policy command. It shows CTS policy SGT 113. It gives me a ACL, CL demo 113, and gives me, it's in monitored mode. So you can see it on the switch. On any switch, which has downloaded the SDACL. And it downloads the SDACL as soon as you have a group tag assigned applicable to this access list. So in my static configuration, even if I don't connect it, the SDACL will be downloaded. In an 802.1x environment, the SDACL will only be downloaded if an identity authenticates for the group tag 113. And this preserves my resources, right? So it's fairly quick. So we don't talk about minutes or seconds, it's really instantly. If I connect it, the contract will be updated. So this one is in monitor mode, but you also see this is my access list. It denies for SSH, for ICMP, it permits for SSH and it permits for any, obviously, and I can change the default behavior. You can do a default rule of deny anything, right? It's a bit critical because it denies for everything. And depending on the version, this is also applicable for the uplinks of the network infrastructure. So if you do go for a deny default list, be very careful. There's a warning. Follow the steps because you need to make sure that your uplinks are not being impacted and routing is not going to be down. Right? I want to give you the best practice and the tips because I saw customers who brought down their labs. Luckily, only the labs and not the production environment. So deny default, be careful. It works perfectly, but there are 2 additional steps in here. Okay, we are still in monitor mode. I can now, as you can see here, enable and disable it. I can. Oh, I can use both simultaneously, that's fine. Enable, disable monitor. If I disable it, nothing will happen. I will just remove the access list from the device because the contract is not, active. So I'm gonna enable the environment, save now. And the fun piece is nothing changes. Even my communication, because we filter ICMP, right? We didn't ping. That's good enough. So we are pinging again. So all of this keeps working. Nothing happens. It's just saving the contract in the metrics. The thing to activate is really you need to deploy or schedule the deployment. And this mitigates that somebody does crazy things, right? I don't like the extra step, but it is there for a reason. So if you misconfigure something, it's not really impactful. If you press deploy, this is really give you then the next step and say, okay, here we go. You see, it's stopping. It's not, the sequence is not counting up anymore. Nevertheless, if I do my SSH, for example, you see, it's still working. All good. So I'm connected over the interface. As simple as that. No rocket science. There's another question.
Cisco can develop some kind of mechanism to prevent affecting uplinks.
Yeah. So the question is are we developing something to protect that the uplinks will be impacted if I misconfigure or go for a deny default list? There's a warning as far as I know. I think we changed the model. We are looking into this to protect the uplinks because they are not participating in SGTs anyway. Yes, we are looking into this. But it's really depending on the version. I didn't check the 2.3.5 because it's brand new. I got it last week. If this is already in, but definitely that's something we look into. Okay, here we go. So we have this communication in. This is the demo we have done. And the configuration, which I've shown you all in the live. We have all this for you as a reference in here. A couple of commands where you can look into what ACLs are configured on the device, in which mode are they, which SGTs are propagated to the switch. And you will only see the required information on the switch. It doesn't really pull anything which is not required. Good. Let us focus on this one and go some under the covers for the last couple of minutes before I release you. I don't know if there are some drinks at the World of Solution today, but at least we are already in the final 4 or 5 minutes of the session. It's a quick hour. I'm very happy. I had 45 minutes in Melbourne. It was way too tight. So I'm lucky because now I can go through this slide because it's pretty important to understand. Forget about the upper piece. I have the second slide on control plane. So imagine the control plane is up and running. What happens if a packet arrives in SD access? You have the edge node, the access port, and the access port will take the regular IP frame. There's nothing, right? It's just a pure IP frame. Source destination IP, protocol, and source destination port. That's it. All the lookups, DNS, ARP, default gateway, everything is exactly working the same way, but it's all covered on the edge node. What we do is we take the packet, we encapsulate it into the VXLAN header with the assigned virtual network. And if I know it's SGT113, as you saw in my demo, we will attach the SGT and do the binding of the IP address to the group tag. It's listed in the switch. ICE will learn about this if it's integrated with DNA Center. And we forward this to the border node. The border node will then copy this frame without the VXLAN header to the trunk. And if you did the manual configuration step on CTS, it will also copy the SGT. If you don't do this, the SGT is going to be lost. The CH will then do the same thing. It will, of course, decapsulate the 802.1q packet. It will recognize, oh, this is the group tag. This is the VLAN. The VLAN is being mapped into the virtual network, the VPN and SD-WAN. And then I will forward it according to my OMP routing table, right? I find the outgoing interface because of the routing, and I send it then to my encryption process, send it out to SD-WAN, to the corresponding CH on the other end, right? So this is actually what happens inside the box. If you have quality of service in, we also take care about quality of service and copy the quality of service bits over. There's an application policy in DNA Center which completely auto-configures quality of service, but gives you a full table of influence, which applications are belonging to which class, etc. So you can do all of this. Okay? So packet in, packet out, reverse path, it's exactly the same thing. On the control plane, it's a bit different than in regular because we have many routing protocols in charge. So we do have in SDX's underlay, by default, if you do LAN automation, IS. You can run OSPF if you do it manually if you want. We have the RLOCs. We have locator ID separation protocol as my mapping database for the overlay. And in SD-WAN, we have the TLOCs, not RLOCs, and we have OMP on top of this. So that's what we do. The next thing what happens is if you configure the handoff, BGP takes care about aggregation. It will always aggregate to the IP pool you assign to the virtual network. In my case, 172.20.195.0/25. All the list stuff is running on /32s. It's all host-based routing if you want. But it's DNS, it's Lisp, it's super scalable, it doesn't matter. But your SD-WAN most likely don't want to have millions of host routes in it. So we take care about the aggregation by default. If you change the IP pool and the environment, we take care of this as well. the change is a bit tricky. The same happens, by the way, on the OMP end. If they have /32s, they're going to aggregate the same thing. And you can also configure it the way that you only see a default route in your branch. You don't necessarily have to have everything, right? So that's what we do. And in the middle, we have external BGP. If we automate it by DNS Center, because DNS Center can only automate external BGP, right? There's no other routing protocol. Means you need to enable external BGP on your C edge. And then you have MPBGP if you want. You have your address family with a virtual network name, and that's how you stitch everything together. Means your virtual network from VXLAN goes into the VLAN, goes into the VPN of the C edge, into the address family of the routing, and will be propagated out the world. Cool. That's pretty much it. That's one time through the packet walk of an SDAccess to SD-WAN integrated network. Why do we do this? We want to automate, of course, the fabrics on both ends. We want to automate the IP pool distribution through routing protocols. We want to simplify the way, except the manual configuration on the trunk interface of the border node, the configuration for TrustSec, and we're going to give you the flexibility to do microsegmentation end-to-end, well knowing that we didn't talk about ACI today. It's a different session, and we can go into details if you're interested in this one. We talked through the vManage and DNS Center configurations. Some reference to read with. If you're interested, I will be around in the next couple of hours. I will be around tomorrow until Friday. If there are any questions, please come and join me. Otherwise, use automation, figure it out, test it out in the lab, so that you can really focus on what matters instead of really going through into every detail, but it's all about the NNI, the network-to-network interface. It's like 20 years old, but it's still a lot of fun, because routing, this is where I was born into IT, so that's what I do. If you're interested, we can also co-work together, bring it up in your lab, test it out in your lab, bring it in production. There's a lot of we can do for you. For now, thank you very much for joining my session. Enjoy the rest of the day and the rest of Cisco Live. Thanks for being here, and I wish you a happy evening. Goodbye. Thank you.